Hello YouTube viewers. This is the VisionTech Radeon HD 4350 graphics card from my home theater PC. It's been in 24/7 service for the past 4 years and has worked quite well with one irritation. That is the cooling fan. These little fans are just not very reliable, and only 9 months after installation the fan started making noise. And rather than go through the hassle of a warranty return, I removed the fan and lubricated it. Now, of course, I had to do this several times in the intervening years, but the last time that I checked on it, I found that the fan wasn't turning at all. So as a quick fix, what I did was I left the fan out altogether and put this right next to the graphics card. Now this worked for keeping the graphics card cool. It's also quite noisy, as you can hear right now. And that's on its low speed setting. On its high speed setting, yeah. So what are my alternatives? Well, I could just buy a brand new card, because a passively cooled HD 6450 is the same $40 that I paid for this card 4 years ago. But why replace this card when it works fine? I could put a different fan on it, and I have one right here that may be of a little bit higher quality, but it is really noisy because it's a high-speed fan. Or we could turn this card into a passively cooled card. We'll just remove this heatsink and put this on. Now, doesn't that look great? Now, I do have several other heat sinks that I considered, specifically CPU heat sinks, because they do have fans on them and they're a little bit smaller. But if we go with the fan, then once again we have a moving part that could be unreliable and noisy. So I think I'm going to try the passively cooled option. Positioning of the heat sink is going to be just a little bit fiddly since we're very close to components on both sides. I suppose I could trim the boss off on both sides, but I'd prefer not to. And we're going to be rather close to the mounting holes, or the mounting holes are going to be very close to the edge. But from what I can see, that's going to give me enough space for the fins to clear the PCI slots. I have carefully positioned the original heatsink to use as a guide for drilling the holes. I've put the heatsink in the drill press and I'm ready to drill my first hole. Now I'm ready to drill the final hole. In the course of this, I've been using WD-40 as a cutting lubricant. I found on the internet that WD-40 or kerosene works adequately for drilling and threading in aluminum. But I haven't been spraying it directly on there because that would make a mess. What I did was sprayed some in a little cup, and then I use a screwdriver and just do like that, and it will run down the drill bit. And something else I've been doing is when I get it positioned, I will press down without turning it on and make sure that it doesn't move when I put pressure against it. Make sure that the heatsink doesn't move around when I put pressure on it. Okay, so let's get a little bit more WD on it and do the last one. And there we have it. Now we're ready to tap the holes that we drilled. Once again, I'm using WD-40 as a thread cutting lubricant, and I put a little bit down the hole, and I've also dipped the tap in it. So now if we can hold it straight and get it started. Okay. I think we may have bottomed out. Let's remove the tap. Let's wipe the oil off of it. Now just try the screw in the hole just to see what happens. And yes, it threads right in. Now the hole needs to be cleaned out, of course, before I try to run the screw all the way down. And I'll do that with compressed air. Alright, I'll get the rest of the holes tapped and we'll move on to the next step. The holes have been drilled and tapped. The heatsink has been cleaned of all the cutting fluid, and I think we are ready for a test fit to see just how everything goes together and if it goes together. And here we are, ready to install. I dry fitted everything without heatsink compound and made sure that all the clearances were correct, and it fit right in, didn't interfere with anything. So then I disassembled it, put some heatsink compound in between the GPU and the heatsink, and I used this OCZ freeze. Now let's see if we can get a look in between the heatsink and the board, and I put a little rubber washer to keep them spaced out. Now it looks like the board may be warped just a little bit, but I'm not going to worry about that because, well, it is a cheap graphics card, and if it fails, well, then I guess I'll just get another one. But it was an interesting exercise, and also I put little rubber washers underneath these screw heads so that they weren't contacting the board directly. And in the course of fitting everything together, I did find that I had one screw hole that was just a little bit shorter than the others, so I had to trim one of the screws off. So, how did I trim the screw? Well, if you have one of these combination tools, if you don't know about it, these holes right here are screw cutters. You'll notice that the screw designator is printed right above it, 1024 for a diameter 10, 24 threads per inch, 1032, 832, 632, and 440. You may recall that I said I used 440 screws. Now I have a sacrificial screw that I'm going to demonstrate the cutting. What you do is thread it in to the hole. You have to open it up so that the holes line up, just like that. Now thread it into the hole to the depth that you want it to be cut off to. Now if you look around on this side, it's going to cut right here. So the screw is going to be just that much longer than what's sticking out the end here. And then you simply squeeze the handle. And usually it goes flying. So let's see what we can do. There we go. Now then, that's cut off. There it is. Now, where is my handy dandy tool? Here we go. Now, I usually run it back and forth a few times just to make sure that it straightens the threads out nicely. And take it out, and there you go. It's not going to be very pretty. You can dress it with a file if you want to, but I didn't in this case. Here it is in the system and running. I know. Cable management is atrocious in this system, but it's always closed up. No one ever sees it, except for now. Now I've just started the system, and of course it is open, so air circulation is going to be at its best, I would think. Now it always idled with the original heatsink and the twin fans running on it. It idled between 35 and 40, just depending, and right now we're getting, well, 30. $29 or $30. Sorry that it won't focus. And ambient temperature is 70 degrees Fahrenheit. Okay, so I'll put the cover back on it and let her idle away. I may even run a test or two and see what happens. As you can see, the system is all closed up and has been playing videos for about an hour or so. And it's holding at about 38 degrees. Room temperature is still 70 degrees Fahrenheit. Now, as I mentioned earlier, the video card would idle at about 38 to 40 degrees, and that was idle. And when playing videos over an extended time, it would get up just nearly 50 degrees centigrade, or Celsius. Centigrade is the old term, yes. I learned a little bit about the metric system a long time ago when I was in school. So it looks like this is going to be a very good modification for this card. If you have any questions or comments, just leave them in the space below. And as always, thanks for watching.